A very good morning to all of you. Thank you for joining us. I'm Vasudha Sridharan, and on behalf of Cumulus Networks, I'd like to welcome you all to Powering VMware EVO SDDC with Cumulus Linux webinar. Presenting today will be Nishant Satyanarayan and David Sin. Nishant is in business development and manages the VMware Alliance at Cumulus Networks. His career has spanned business development, sales, and technical leadership roles from early stage to growth companies such as Nimbula, VMware, and LoudCloud. David Sin is a networking professional with over 25 years of diverse experience on both sides of the table, from supporting customers and developing solutions at Cisco to designing and building worldwide enterprise and cloud infrastructure at Microsoft and Amazon. This webinar will be about 30 to 45 minutes. We will answer a few questions from the participants at the end if time permits. For those of you interested, you have the opportunity to ask questions during the webinar by using the window marked questions. Simply type in your question and click send. You can also tweet your questions to us. Our Twitter handle is @CumulusNetworks. And with that, I'd like to turn this over to Nishant.
Thank you, Vasudha. And greetings to everybody on the call here. So in terms of agenda, I'm going to open with a little bit of background and history of what we do at Cumulus Networks, how we do things, and then I'm going to segue to providing a high-level overview of what the EVO SDDC suite is, which is a software bundle deployed across prescribed hardware manifests. And then I'll aim to address why the solution is important for customers. And then I'm going to hand off to my colleague, David Sin, who's going to go a little deeper around product architecture, how things are packaged up, different pieces, and then we'll tie back to why Cumulus Linux was selected as a technology partner, essentially becoming an embedded software component within the EVO SDDC suite. And finally, we'll aim to pause for Q&A in approximately 30 minutes, as Vasudha has indicated. So let's get started. You've got the slides. You guys can obviously follow along here. Open networking is a key concept here that I want to cover. What does open networking offer? Essentially, what is it accomplishing? And so open networking, by definition, is about leveraging network disaggregation. This means decoupling the components of an integrated networking system from each other in order to give customers the option of selecting the different hardware and software components used in building and operating networking switches. And so let's look at an example here and kind of put this kind of concept into practice. And so if you kind of look from left to right, we've seen this disaggregation model play out really in the compute paradigm. We've seen this play out over the last 15 plus years. So on the left side, you have this kind of highly integrated, vertically integrated, highly proprietary system from proprietary CPUs to the proprietary operating system to a limited number of applications. And all the way up the top, you've got architectures that are largely proprietary and tools to kind of manage this infrastructure. And so if you look at the left, you've got kind of a limited number of vendors that kind of support each of their various flavors of this type of model. And so we almost kind of take for granted what exists today in kind of Web 2.0, where you can see on the right-hand side, you kind of see this notion of disaggregation at each layer. So you have really what is a standard CPU x86 architecture. You've got this notion of Linux as a standard operating system, more or less ubiquitous in the data center. You have, in the red box, you have this kind of burgeoning kind of vast ecosystem of applications that are kind of built on top of this platform to provide management, to provide monitoring, all these value-added applications. And then at the top, you have this notion of orchestration and automation, which is kind of paramount in today's distributed computing world and model, where you have heterogeneous infrastructure across distributed data centers, and you have kind of a standard set of tool sets to kind of manage that infrastructure and to automate it, drive efficiencies at scale. And so, in the middle, you kind of see in the middle here, you see a bunch of vendors, and I think there's an important theme here that I'll just touch on. As we kind of think about, what open networking really offers, it's this notion of kind of choice, right? Choice of hardware, choice of software, ease of use, et cetera. And so let's kind of look at, where we see the networking industry today and this paradigm shift. If you kind of replay, what we just talked about, we're kind of at the beginning of disaggregation on the networking stack. And so, if you look on the left side, a very similar box here, you've got this notion of proprietary stacks, integrated with the proprietary OS. And obviously that means complexity in kind of complying and working with specific operating systems that are driven by particular vendors. The promise of open networking and kind of where we see networking moving towards in the future from today to kind of onwards is that similarly to the compute stack, you have disaggregation at each of the layers. And again, why is this important? It kind of means that you have a choice of hardware, you have a choice of software. It means ease of use, it means automation, it means CapEx, OpEx reductions and savings. And those are kind of critical components as we kind of think about how Cumulus Linux and Cumulus Networks fits into this EVO SDDC offering, and kind of why we're a critical technology partner for VMware, and ultimately what that means for our end customers. So sort of in the middle there, you can see Cumulus Networks, and ultimately what's driving this notion of disaggregation and open networking. It's this opportunity to apply Linux, really a Linux networking operating system, to provide some commonality to how you might manage networking switches and routers in a consistent manner. And so what basically, generally kind of from Cumulus Linux, what is it essentially? It is essentially, as I mentioned, a Debian distribution. It is truly a Debian distribution based on Wheezy, but we've also built a component that we call switchd that's basically a hardware abstraction of the Broadcom SDK. So you can kind of see on the bottom right across the merchant silicon, we basically have we have the mechanisms that support Linux being able to talk across the Broadcom ASIC, and to do that with the data plane through a pass-through that we have created with the switchd. And David will talk about that in a little more depth. Also, an important point is that we allow you to interface with the machine, the CPU subsystems, the sensors, the environment, much like you would a traditional machine. So all of the goodness and DevOps tools and configuration and automation that you're kind of building and building both capabilities and automation through on the compute stack, those are kind of translating over into the networking space. As we kind of move forward here, today we focus on the data center switch market. And so what that translates to is kind of this notion of 1 gig out-of-band management switches connecting, of course, out-of-band management ports, leaf and spine layer switch, which oftentimes is a 10 gig top of rack. That spine layer could be 10 gig or 40 gig. So again, if I kind of think about and build on the concepts that we sort of discussed and around open networking and disaggregation, what does this really mean, right? If you take stock, take a step back, what does this really mean, both from the customer point of view, so that's one angle, and then also I'll kind of tie it back to why we were kind of the first technology partner that VMware looked at from an overall partnership perspective within the SDDC suite as they consider launching this. If you think about what choice offers, we now have a whole host of configurations that we support. So there's some 30 configs today across 70 manufacturers. So the open networking promise is that effectively it's open at all layers of the stack, right? So if you go back to the maybe a couple slides before, and you think about the proprietary vertically integrated system versus kind of the open networking system, choice becomes a really critical component of this. So you have choice of vendors, whether it's EMC of hardware, whether it's HP, whether it's Dell, whether it's Supermicro, whether it's Quanta, or any combination of both. You might want to have a multi-vendor strategy. You now have that ability to run Cumulus Linux across this kind of vast ecosystem. It also becomes an important part of how and why VMware looked to Cumulus Linux to partner within the EVO SDDC suite, knowing that VMware's go-to-market partners, we have convergence sort of overlap with supportability of ROS across their networking switching hardware. It made the ability to kind of integrate and build once and kind of distribute across a number of OEMs to kind of accelerate go-to-market. As I sort of also move up the stack, so if you look at where the app boxes kind of sit on top of the operating system, You can also think about where open networking and choice sort of comes into effect there at the higher level layers of the stack, whether it's through automation tools, through monitoring tools, as you kind of see on the top right. You're able to kind of take advantage of the innovations and standards that you're kind of driving around DevOps, around automation that exists in the compute stack, and sort of move that into your networking management model. And so you can kind of think about networking, folding networking into the same tool constructs that exist on the compute side, and then more or less you can think about DevOps not just as a crossover concept, but also a common operating model across both compute and networking. So it's quite powerful. Lastly, I want to touch on the CPU, and there isn't a graphic there specifically to support that. But when you think about the CPU, in and of itself, historically CPUs were fairly lightweight. They're really, within these networking devices, they're really meant for control plane processing, right? Spanning tree, routing protocols. They were typically single-threaded, and that's all they did, right? Just focus on the control plane. You kind of fast forward to today, whether they're customers or partners, whether it's VMware in their kind of go-to-market, they're really reimagining how to build applications on top of this software architecture that's evolved from Linux through its modular approach, being multi-threaded, and becoming quite sophisticated. And so there's an interesting kind of vast ecosystem that's now sort of developing on top, and what you can do in terms of integration, in terms of management control and automation is becoming very, very powerful. So I'm just going to quickly pause. That was a very, very brief introduction to Cumulus Linux to give you guys, for those of you that may not be aware of what we do. I now want to segue over to VMware's EVO SDDC suite. It's a bit of a tongue twister, and kind of talk about why it's relevant from a customer perspective, and then also why is it that we're excited to be part of this, and what problems are we helping solve. So if you're an enterprise that kind of operates data centers, and it's probably there's a set of KPIs here. This is not exhaustive. I'm sure that nothing I have here is new to anybody that may be on this call that sits in that seat. But ultimately, you're being measured by the rate at which you can simplify your operations, how you reduce your operating costs. How do you ultimately get to a Borg-like infrastructure where you can simply kind of pull out boxes, add them, add the capacity, and it just kind of automatically works via plug-and-play model across a high-capacity, cost-effective infrastructure. And you sort of need to do that in context of your existing infrastructure, right? You've already made existing investments in capitalized infrastructure, whether it's routers and switches. You've already built highly customized applications that kind of exist in a classic IT construct. And so you kind of have this conundrum, right? You're being measured against web-scale companies that kind of operate with razor thin in terms of operational costs. They're kind of leveraging open compute, open networking standards, and are really trying to figure out how to really drive costs out. But more importantly, how do they kind of run across bare metal components, whether they're networking or infrastructure, and what's the right software architecture to support that? And so if I kind of transition a little bit here to what is the EVO SDDC suite, VMware recognizes that burden, that ultimately there's a lot, IT is going through, enterprises are going through a bit of a transformation where they're really beholden much more than they ever been to how responsive they can be to the line of business. They're needing to create self-service offerings, which may include private clouds for infrastructure as service. It may be for virtual desktop offerings. It could be to support web scale. It could be to support SaaS, right? It could be for big data. It could be any number of different workloads that require real-time kind of elastic compute. And ultimately, the line of business needs reliable, scalable, performant, cost-effective cloud computing. And so what VMware has recognized is that there needs to be a bridge. There needs to be a way to provide kind of a transition from where an existing customer may be at today to kind of this notion of turnkey, fully integrated, cloud computing, right? Which kind of shows up. You literally can power rack stack, power turn on and sort of walk away, and it should sort of work, right? You should be able to get access to infrastructure. The networking complexity should be, which is really a lot of what most enterprise customers have to deal with as they kind of start to take a la carte components, whether it's the storage, whether it's the networking, whether it's the compute, and then have to kind of parlay that into a hardware solution, and then also make the networking scale, right? So how do you scale across multiple racks? What's the right topology, whether it's layer 2 or layer 3? How do you make that all work? And so VMware's answer is one of the answers, I guess, is the EVO SDDC suite that runs across the prescribed set of hardware. So, again, I want to restate that, we as in Cumulus Networks have become an integral component of this overall solution, masking the complexity and adding, additional racks to managing the physical networking topology and managing the physical networking hardware. We become a critical component in kind of driving out cost and simplifying operations. I sort of covered a few of these benefits. I'll just kind of restate them. Again, I think that the key here is that the game is sort of changing around how an enterprise stands up, the time it takes to stand up and get access to on-demand cloud computing, again, by masking a lot of the storage, the networking, the compute complexity, the setup. Ultimately, you should have one individual, one admin that should be able to kind of come in there and do some very basic entry, and you should be able to rack stack servers with these converged systems and get some simplicity in setup. Lastly, I sort of touched on some of these use cases, but again, you almost want, you notice there isn't a lot on the networking piece because you almost want that to sort of disappear, right? And ultimately, what we want is to mask all the networking complexity and really to be a seamless kind of integration layer to offer, infrastructure as a service. And in these cases, these are primarily the two go-to-market sort of use cases that VMware sees around their offering, and that we'll likely be supporting. So with that, I know it was a very kind of quick overview, but I wanted to hand it off to my colleague David Sand, who's our technical director here at Cumulus, and he can drive through the deep dive and on the architecture and some of the connecting points back to the offering.
Thanks, Nishan. So let's dive into what we are, what we're doing, and why VMware and for their EVO SDDC solution picked us, because there are some unique things that you can do on top of Cumulus Linux that may not be as obvious on other platforms. So if you look at the evolution, sort of similar to what was presented earlier about how the compute model is changing from sort of mainframe to very open compute, that same sort of network evolution is also occurring, and we are one of the enablers of it, where we are moving from traditional monolithic operating systems that are running on network components to a slow evolution to leveraging Linux, as you may find from other third-party operating systems where, say, Linux is leveraged to start the box, to memory manage, to handle files and such, but you're still within a limited, protected, closed shell of the command line that they're trying to give you, where you don't really have access to the full box, and automation is going to be very specific to which of the different platforms you've chosen from, because each of them have different command structures, different APIs, different ways to access the system. One of the things that we saw as is happening in compute, Linux has become the lingua franca of the data center. And so one of our goals is to bring Linux and the openness of it and the consistency of it and the ability to do different things on top of it to the networking environment. So we are not built on top of Linux. We are a Linux distribution. So what this means to you is that when you go and look at leveraging Cumulus in your own environment, or as VMware did with their EVO solution, what benefits do I get from this is it's not a proprietary, not Linux-like. We leverage the standard Linux command structures that have been there for a long time to be able to go do traditional routing and switching as you would normally find inside of a network environment, but doing it with the consistency and the accessibility that you see with the traditional IP commands inside of Linux, with third-party applications for routing such as with Quagga, or others that you may want to be able to solve the problem in your space. What we fundamentally do is leverage what's going on inside of the Linux kernel and push it down into the hardware. So the software is not forwarding. You get the full raw hardware line rate performance as you see from the hardware platforms that we're running on. We just use the Linux kernel as the way to build those structures and then transpose that down into the hardware. The big upshot of this is the applications that you may be using on, say, a software-only platform now have the access to run on a hardware-based platform. So what I get is my automation tool can be identical on this platform as I may have on my servers. Just as I said, we leverage Quagga for routing. We didn't have to modify Quagga to work on our environment. All we've done is gone in and made improvements or found issues where there may be in Quagga and fixed them both for us and for the broader community. And so what this does is this allows us to have standard VXLAN configuration options, as you may see inside of Linux, that now automation tools that know how to do that, configuration and overlay tools that know how to do that inside of Linux, naturally work on the hardware platforms that we have that support VXLAN offload. So these benefits were really chosen because we wanted to give that ability to work across software platforms and hardware platforms consistently so that you weren't pigeonholed into one command line or one API as you may see in the existing environments. Now, how do we actually do this? So it's actually pretty simple. Not super simple, but it takes a little bit of work. You have to know the chipsets that you're running on. But fundamentally what we do is all of the configuration, all of the provisioning, all of the automation, all of the monitoring happen through the traditional Linux kernel, just as if it would occur on a standard software-only platform. The important part that we have is, as you can see over on the right, we have an application called switchd. And what it does is it listens to the kernel and looks for all network changes and pushes them down into the switch silicon. Similarly, it takes the data that the switch silicon is learning itself, automatic learning of layer 2 MAC addresses, interface statistics, things like this that are occurring in hardware. It pulls it out of the switch silicon and pushes those statistics and updates into the Linux kernel so that you see a very consistent experience just as if you are on a software-only environment. What this means is, like I talked about, is you get this very consistent ability to configure, leverage third-party applications. Like I said, we prefer Quagga and recommend Quagga as the routing protocol suite for OSPF and BGP that you use with Cumulus Linux, but we have a number of customers that say have been working with Bird for years and want to leverage Bird as the routing protocol. No new thing had to be done to be able to leverage Bird on our platform. It just was to replace Quagga with Bird and run with that as your routing protocol suite. Similarly, we've had customers that say have wanted to do their own traffic engineering, and they've been able to write their own applications that are able to then go and push routes or make configuration changes or do what they need to do on the platform through industry standard Linux configuration options that we then pick up and push down into the hardware. So as you may guess, this was one of the biggest reasons that the VMware team, when they started going down the EVO SDDC solution, wanted to have this very consistent interface that they didn't need to go and build a lot of third-party applications for or translations for, but were able to layer on top of the existing infrastructure that we have. And because we're Linux, you also have the ability to go run other applications on top of it. We are a Debian Wheezy distribution that you can go and compile applications to run on here to act as a file server, act as a web server, act as your TFTP boot server, run IPMI tools to go and manage the locally connected host, leverage the LLVP data. I mean, the options you have to go pick on what you may want to do, since we are a traditional, think of us as a server with hardware acceleration. Now, while that may scare a few people, or you may be thinking, well, that's not how I do things with my traditional network configuration boxes. Say if you're already deploying iOS or already deploying JuneOS or any of the other sort of traditional network CLIs that are out there. The important thing to understand is we are not telling you how to change networking. We are not saying you have to do everything by flow. We're not saying you have to rethink everything that you do. This is more akin to learning a new way to configure it. So the important part is not that we've changed the fact that VLANs exist. All we've done is we've leveraged the Linux configuration options for provisioning VLANs, as opposed to, say on Juniper you do it one way, on iOS you do it another. We're just another way to do that, but we do all those same traditional things. Like I said, switching, Layer 2, Layer 3 routing, BGP, OSPF. It's really just where things have moved, but you can do all the traditional things that you're used to. But we didn't quite stop there. One of the things that we did is we looked at the large-scale data centers that are being built, the multi-tiered class environments, leaf-spine sort of designs that are out there. And we've invented or added a number of technologies to our platform, to the software that we release, to be able to go and make your life easier in these environments. This is just a real short list. I'll hit a couple of them really quick. ONI is the Open Network Install environment. This is how you get different operating systems on the open networking hardware, and we are one of those operating systems among others that are out there for the choice that you can pick. Think of this as sort of Pixie, but for network with a number of improvements since it was created fairly recently. ZTP, this is sort of a first boot, zero-touch provisioning, ability to go give the box a Bash or Python or Ruby, or I think there's one other one that you can pick from, sort of script to go and execute when the system first starts, to be able to go do basic provisioning, install Puppet, install Chef, check into a configuration server. The word is your oyster. It's just the first boot script that you get to go do to start doing the provisioning of the system. PTM, or Prescriptive Topology Manager. This is a way to go and provide the box a network topology in a dot format, which is a standard-based way to describe a graph, and to go and have the system find itself in there and go verify that all the cables are connected correctly. If they are, you can make the box react to that. Turn up OSPF, don't turn up OSPF, run a script. So options to go and verify that things have actually been provisioned the way that you want. Similarly with network virtualization, like I talked on, we do VXLAN hardware offload in the platforms that support it. We use the standard Linux configuration commands to go do that, so it allows third-party applications like NSX, ones that we've invented ourselves like LNV or lightweight network virtualization, or even custom-built ones that you may want to go do hardware offload of the overlays in a VXLAN environment. These are now enabled on the platforms. We also have a new feature called Redistribute Neighbor. This gives customers that are not interested in sort of that L2 model but want to do an all L3 model to go and take the learned ARP addresses of directly connected hosts and inject that into the routing protocol suite. So now that I can have dual homed hosts or be able to move hosts in the data center without having to have an overlay. Another one that's there, but it's a little obscured by the icon, sorry about that, is unnumbered interfaces. When you look at the richly connected L3 infrastructure of a leaf spine design, there are a lot of point-to-point interfaces there. So unnumbered interfaces is a way, both with OSPF and BGP, to go and not have to provision discrete IP addresses on all of those point-to-point interfaces, but be able to leverage link local or reuse the same address across it and still have your IPv4 and IPv6 reachability, just without having to do the very heavy IP administration that occurs. Now this is just a teaser of all of these features. Definitely we can dive very deeply into any of these offline with your account team. Please reach out to us if you're interested in more information on those. And a number of these we have done previous webinars that you should be able to have access to be able to go and dive deeply on them. This is just sort of an introduction to them. If we move forward and look at sort of what options are out there in a data center today, they really fall into three major camps. You have the traditional L2 network that's using MLAG active-active with either dual connected hosts or not. all L2 with an L3 edge, either sort of at the aggregation or spine layer, or even at another layer higher than that. But this allows you to do the drop-in, just move machines around because VLANs are everywhere, and allows them just to pick up the subnet that they need to be connected to. That's an extremely popular one. We definitely support that. That's one that is widely used today. Another one that is also more as popular is sort of the IP fabric. That is, I'm just going to have an L3 infrastructure. I'm going to get wider ECMP, so I have better data bandwidth within my data center with fewer tiers, and it's very, very scalable. And machine agility may not be as important because I may be using load balancers or firewalls or other ways to abstract where the machines are, or even sort of software overlay inside of the machine itself. But just it goes across the raw L3 fabric, and machines can move around as they need based on the fact doing a software overlay. That is also a very popular one that scales very, very large. And then the final one is sort of the fusion of those two. That is, I do a traditional IP fabric for my underlay, and I do a network overlay on top of it, say with hardware offload with VXLAN. And again, that's one that is very popular. But all of these are ones that we are widely deployed on. That definitely are options for you if you choose to use Cumulus Linux in your own environment. So now that I've sort of set the landscape of what we can do, let's bring this back to why we are a partner with VMware for their EVO SDDC solution. So as Nishan touched on earlier, it is really meant about making a fully automated sort of integrated solution that you can get from one of VMware's partners to be able to go and get a full rack worth of capacity that has sort of auto provisioning installed inside of it, that allows you to go and bring up a very fungible, very dynamic, vSphere-based solution with vSAN running underneath it, and then NSX and other overlays that are running on top of it, and all through a single management paradigm of the EVO SDDC. So the important part about that is that they needed a very consistent interface to be able to go and do the networking provision, just as they see within their own tool and solution set of the vSphere solution. And so this was one of the reasons that we were chosen, is that because we have the ability to easily add applications that have full access to the underlying hardware. The rack management software can run inside of the out-of-band management switch, the data plane switches, to go do the data collection that are needed, and also to be able to act as the provisioning agents that need to go and set up the VLANs or the routing or whatever is needed for the customer environment where the EVO SDDC suite is being installed. This allowed them to have a very consistent interface, as I touched on, a very easy way to go and do the automation, to be able to make it very simple for it to go into customers' environments, and also to be able to manage the entire life cycle process of this. So one of the things is, because we are a traditional Linux solution, the ability to go update packages in it, say to be able to do security patches, say for places like OpenSSL had a problem a while back. The Linux community got together and fixed that. It was posted to Debian within early in the morning one day. That same day we were able to go and turn around and validate that had no problems on any of the Cumulus Linux deployments. We were able to publish that Debian package to be able to go and add on to Cumulus Linux systems without having to restart the whole switch. So this would allow the likes of VMware with their EVO SDDC suite to go and pull that in, do their own validation, and push that out as a patch into the solution that would then go and just tactically upgrade the SSL libraries on the switches without having to take the whole environment down, without having to take a whole new image on the switch platform that may take months of regression, both in EVO's own internal testing and say even in a customer environment where now you need to go validate that these new patches are not going to affect the solution you have. Because of the fact that we are Linux, because it is just package-based, we're able to go do the tactical testing that needs to occur to be able to go and validate that it's not going to affect the whole, and do that very simply. This is sort of a deeper dive into it, and one of the things I really want to touch on here that I didn't have a chance to talk about earlier is because of the fact that we approach the disaggregated model where platform choices are your option to go and pick from when you choose Cumulus Linux. This also gave an enabler for VMware to allow them to go and partner with multiple hardware suppliers for the compute and network equipment to be able to go and allow the ultimate consumers of the racks to go and choose what partner made the most sense for them. So this is where Dell and Quanta are two of the early partners with VMware in the EVO SDDC solution. I would expect others to come over time, such that our operating system works across multiple hardware platforms. This gives the customer choice of which partner that they want to go with, but still having that same sort of experience in that it is an integrated solution from VMware that has a consistent topology, that has a consistent experience through their tool chain, but giving you the ability to go pick and choose the different equipment that you want. So if we sort of roll this all together and kind of look at how this all kind of nets out with vSphere and VMware, their HMS platform to manage us, and then the SDDC manager on top of it kind of coordinating all of it. This gives a very consistent L2 design with MLAG and STP today, with the ability to move to a robust L3 architecture over time. The VMware NSX integration with the ability to do hardware offload is there as that needs to be enabled, and this allows a very easy automation to occur because of that consistent environment like I was talking about. And the important part is it gives that very consistent, scalable approach for all of the different network components in there, and the ability to add packages as needed to be able to go and manage deeper than you may be able to get through a limited CLI or a limited API. And so in conclusion, our Cumulus Linux in general, and then in specific with the EVO SDDC, gives the ability for choice, different hardware platforms that fit, different partners that work better for your environment. It gives a very thorough automation because we are just leveraging Linux directly, and it allows you to do a lot of very rapid business innovation. This allowed VMware to be able to go and build on a very consistent interface and get their EVO solution out very quickly. And similarly, in other environments, this can allow you to go and build automation or leverage existing automation that may be out there for different parts of your network other than, say, just where the EVO solution may be fitting. So with that, I'd like to open it up to questions, and thank you for listening so far, and we'll see where things go.
Great. Thank you, David and Nishan. It was a very informative presentation. We have a bunch of questions coming in, so we'll try to get through as many as we can. The first question is, what is the difference between integrated solutions and disaggregated model?
Yeah, so that's a really good question. So the disaggregated model is to say I can pick and choose different components at different tiers of the network for the flexibility that gives me. So for instance, in a hardware-based perspective, the disaggregated model allows me to go and pick the form factor that makes the most sense for the deployment, be it compute or be it in the network space. The next sort of tier on that is an operating system selection. Which operating system matches the model that works best for me. In compute, there are very large shops that leverage Windows as their compute solution. There are very large shops that leverage Linux, and both of those are options to pick from based on what makes the most sense for you. In the networking space, we are one of those networking options to go on sort of the open hardware that is now coming out, and there are other ones that may fit differently based on your use case. We really hope you pick Cumulus Linux, and we think that's the right one to pick from, but there is definite choice for you, and that also means that we have to show up with the features and functions and support to continue to win your business. That means that we match what you're looking for because you do have this choice of operating system to go choose from on these hardware platforms that are replaceable, just as, say, Windows could be replaced by Linux on an x86 solution inside your data center. So that's sort of where the disaggregated model comes from. When you look at the integrated solution, I mean, the integrated solution can be built of horizontally integrated, closed solutions. It can also be built of, disaggregated solutions based on, how that integrated solution, how that overall managed or overall product is being delivered to the end consumer. One of the things, like I think I pointed out, is one of the benefits that we give of being a disaggregated network solution is that means that, as EVO is partnering, the VMware EVO SDDC solution partners with hardware suppliers for compute and network, they get the ability to go and pick and choose those sort of integrated solutions and have the full choice of buying all of it from one. So for instance, you can buy a rack that is all Quanta equipment. You can buy a rack that is all Dell equipment. I would expect others to be coming in that similar vein that give you that ability to go and have one integrated solution partner to go to for the entirety of it, and not have to go and say, well, compute is coming from me, network is coming from someone else, I've got to deal with third parties to go do that, that you may see in sort of that traditional mainframe model. So they're closely related. You can build ones that are, out of the closed solution, but it may not give you as much flexibility or ability to go to one location, or there could be, you can end up with some finger pointing just because it's not something owned by the one company that you're dealing with.
Okay, thanks, David. The next question is Cumulus a bundle of hardware and software, or just software?
So that's a really good question. So in the EVO specific SDDC case, it is a bundle that is hardware and software. So with that, working with your VMware account team, you go and pick a hardware partner that will go and provide the entirety of the rack with the with the VMware software on top of it, with the Cumulus software on the networking equipment. That all is one SKU that you purchase from whichever of the hardware partners you choose to go with. If we step away from the EVO solution, there are multiple options for you in choosing how to go and consume this for other parts of your network. For instance, you look at the likes of a Dell or an HP, you can get the entirety of the solution with them, which is you go and work with them to buy the hardware platform that fits for you. You get the software license. The software, is openly accessible, or it may even be able to be pre-installed by the account team. Again, that's one to be working with the hardware partner that you pick from, so that you can get a bundle that has all of it from them. You can also choose to go and do sort of the more disaggregated model, that is, go and buy hardware direct, from the ODMs. This is normally for the very large at scale, where you would go and have pick and choose the hardware that you want, pick and choose the partner for the license, or go direct to go get the license, and sort of pick what makes the most sense for your economics and your scale, but not be locked into only one way to go and consume it.
Okay. What is the integration level of Cumulus with VMware NSX? How NSX can use Cumulus for VTEP interfaces? And there is a follow-up question with that as to what would be the selling point of Cumulus with NSX? How can we say that we do better with NSX than Arista or Cisco or OpenFlow switches?
Gotcha. So at this point, so we've had support for NSX hardware offload since our 2 release, if I remember correctly. We are working directly with VMware on getting the full certification as part of their next point release. Nishan, I don't remember the exact point release. Can you comment on that one?
Yeah, 6.2.1 is the next release that will, I think, for NSX V.
And so we're meant to have. Oh, sorry. Go ahead.
No, 6.2.1, I think that's what VMware will release as a GA. I mean, I can't comment for them, but that will be the next, I guess, point release that will have hardware VTEP support with Cumulus.
Gotcha. And so that allows that sort of direct integration where they can reach in and go do the provisioning for us of the overlay. To the question of what differentiates us from the other solutions that are involved with that. So some of the things are that while NSX can reach in and provision the overlay for you, it still doesn't answer how I actually get the original network up and running to build the fundamentals of that. So when you look and compare, some of the things I talked about just bringing up the basic network. I have to do routing. I have to do switching. I have to do provisioning. I have to, potentially need to automate in a non-EVO solution, in just a traditional network solution. I have to go do all this automation myself So some of the benefits that we bring are because we're Linux. We get that direct ability to go and leverage existing tools that are already out there that may already be being used in your environment, like Puppet and Chef and Ansible and Salt, to be able to go and do that basic provisioning to get the system up and running, and then being able to go and then add the overlay on top of it with the hardware offload. That may not be as easy or may not fit into things you're already doing in the existing environment using other operating systems. The other thing that we also can be able to provide is it's very easy to do additional data collection on our solution that needs to potentially jump through hoops or go through proprietary APIs on other solutions. So we're currently working on something that we expect to have out here fairly quick that will go and do a distributed data collection of what's going on in the environment and be able to go and give you a very easy way to go and visualize and look at what's going on that it may not be as easy to go and collect on existing third-party hardware, vertically integrated hardware that's there.
Okay. Are the ESXi hosts connected with a LACP LAC or LBT with the switches to provide a redundant connection?
Specifically within the EVO solution, yes, they are redundantly connected to two top of racks, and they're running LACP to be able to go and provide that redundancy.
Okay. Does it do overlay and underlay management, and will VMware project the underlay management too, or only the overlay?
Specifically within the EVO SDDC solution, it manages the entirety of it. So it manages both the overlay and the underlay, bringing it up, configuring it, provisioning it, and getting it prepared for the connection to the rest of your network.
Okay. Are you optimized for one chipset?
No, if you go and look on our HCL that is up on our website, we support multiple chipsets. They're currently all from Broadcom, as Broadcom's has the best portfolio right now of the commodity chipsets that are out there. There are other suppliers that are in process of developing other chipsets that may make sense for companies to start supporting as the adoption occurs. But there's a breadth of chipsets from the 1 gig platforms to the 10 gig to the 40 gig platforms, and newer ones coming, as the higher speed, 25, 50, and 100 gig interfaces start coming out. We will be supporting chipsets in those families.
Okay. Does Cumulus integrate with NSX for vSphere outside EVO SDDC environment? Is Cumulus supported in the new 6.2 version as a VTEP?
Yes. So as we touched on, we both are supported inside of EVO and then also externally, and we're looking for the certification in 6.2.1 as Nishan commented on.
Okay. Can the hardware which are managed be even 100 gig ports, such as the Arista 7500? What is the certified hardware that Cumulus can manage?
So Cumulus we have an HCL published on our website, hardware compatibility list that lists all the hardware platforms that we operate on. And that lists all of the ones that you can go, where the partners to go to, the links to the sites to go get that, and ones that we're certified on. As I mentioned, 100 gig is definitely coming. The chipset from the manufacturers are still in very early use cases. They're not quite to mass production. As they get to mass production, then I would expect to see those added to our HCL. But at this time, I can't comment on exactly which ones those are. But definitely stay posted. We will have 100 gig platforms announced that we are supporting from our hardware partners.
Okay. There's another question. Is there any way to test Cumulus Linux other than the remote lab, something like a traffic-limited VM?
Yes, actually, we released a couple months back a VM solution called Cumulus VX, or Virtual Experience. So I actually did a webinar on that as well, so definitely go up to our website and check it out. It's a full VM. There's no traffic limitations on it. It's just limited to how much CPU you throw at it, since it does packet forwarding only in the Linux kernel. There's no hardware there. It doesn't run on hardware-enabled platforms. It's just a VM only. so that you can go and do things such as set up a test environment, learn CLI, model things you may want to do in your own network. We also have a community page dedicated to a community area that's dedicated to Cumulus VX and how you can leverage it. We have integration with Vagrant. You can do it manually. You can run on top of VirtualBox, vSphere. You can run on top of KVM and other solutions to go and try this out, GNS3 to try this out. Definitely check out our website on that and look at our prior webinar on it, on how you can go learn.
Great. We are out of time actually, and we got as many questions as we could. And if there are still some pending questions, we'll try to answer them through the follow-up emails. Thank you, David and Nishan, and thank you everybody for attending this presentation. We hope you found this presentation useful, and we'd love to get some feedback via the follow-up emails. Do tune into our next webinar on October 8th, which is Optimize Your Routing with Border 6 and Cumulus Networks, with Francois Devian from Border 6 and David Sin. The details are available on our website at cumulusnetworks.com/webinar. Thank you all for your time today.